This is a video about end behavior, and more specifically the notation we use when we describe end behavior of a graph. So the first parts of your end behavior are the same every time. What I have written on the board is what you will see in your end behavior notation. The only thing that changes is what comes after that arrow. The y is approaching blank. That's the only thing that will change. Everything else will always look like this. Now, you could always have f of x instead of y, so understand that. But the only thing you need to figure out is the very end of both of these lines. So this top line that I have, we read it as x is approaching negative infinity, y is approaching blank. Now, x is approaching negative infinity means that x is headed towards the left. Because remember, the farther left you go, the more negative you're going to get. So x is approaching negative infinity. This is basically asking, what is happening on the left side of this graph? Well, on the left side of this graph, y could be approaching, positive infinity, negative infinity. It can be approaching something on the left side of this graph, and that's what I will demonstrate in the next few slides. The next line, x is approaching positive infinity. Well, if x is approaching positive infinity, that means we're moving towards the right. X is getting more positive as we head towards the right. As x is approaching positive infinity, y is approaching blank. So then you have to figure out, where is that graph going as we head towards the right? So that's how you would read this notation. The first example I have on here is a positive even graph. Okay, a positive even graph means the leading coefficient is positive in the equation, and the degree is an even number. A positive even graph always has this end behavior. I completely blanked on the words. So, in an even positive graph, the left-hand side is going up. Okay, y is approaching positive infinity means that the graph is going up. And like I said, x is approaching negative infinity is what's happening on the left. This other part, x is approaching positive infinity, means what's happening on the right. On the right, the graph is also going up. So positive even graphs always have this end behavior. Now this is an example of a positive odd graph. So the leading coefficient is positive, the degree is odd. The interval, or sorry, not the interval, I keep blanking. The end behavior of this in the notation is telling me that on the left side of the graph, it's going down, y is approaching negative infinity. On the right side of the graph, it's going up, so y is approaching positive infinity. This is an example of a negative even graph. So you can see that as x is approaching negative infinity, y is going down. So on the left, the graph is going down. As x is approaching positive infinity, y is still approaching negative infinity. In other words, on the right-hand side of the graph, y is facing down, or y is going down. Notice in my even graphs, they were both facing the same direction. So if it's positive, both sides are facing up. If it's negative, both sides are facing down. So the last example would be a negative odd graph. Notice the left is facing up. So as x is approaching negative infinity, y is approaching positive infinity. The right is facing down. So as x is approaching positive infinity, y is approaching negative infinity.